In this video, we'll cover dplyr verbs for data wrangling. The R code used in this video is available on the Learning Management System. The data file used in this video is weather2017.rds. You should download these files if you'd like to follow along. By the end of this video, you should know what a dplyr verb is, how you will use dplyr verbs in data wrangling, and what are some common dplyr verbs for data wrangling. When you're using dplyr, you're going to manipulate data using verbs. Verbs are dplyr functions for performing actions on data. Much like in language, dplyr verbs are action words. Each verb is an R function. It's usually going to take data as its first argument, which makes it perfect for using the pipe, because remember, the pipe will take whatever's on the left-hand side and feed it in as the first argument of the function used on the right-hand side of the pipe. So what are some dplyr verbs? We'll start out simple. One dplyr verb is arrange. You use this verb to sort the data in your tibble using the variables that you specify as arguments. The default with arrange is to sort in ascending order. If you specify more than one variable, what R is going to do is sort by the first variable, then it's going to break ties, sorting by the second variable, and so on until all the variables are used. If you'd rather sort in descending order, you use the DSC function on a variable to switch its sort order to descending. So let's use some dplyr verbs in R. The first thing I'm going to do is run some setup code, including loading the weather2017.rds file into a tibble called weather. Now that I have some data loaded, let's look at the arrange verb. In this first example, I take the data in the weather tibble, I pipe it to the arrange verb, and as the argument, I specify average.tempf. What this is going to do is take the data in my tibble and sort it by average.tempf in ascending order. Let's run that. Looking in the output window, you can see now the data from this tibble is no longer sorted by month, day, and year. It is now sorted in ascending order of the average temperature. You can specify more than one variable. Remember, what R is going to do is sort by the first variable you specify, and then sort by each additional variable to break ties. Also in this next example, you can use the descending modifier, it's a function that you apply to variables, to sort in descending as opposed to ascending order. So in this next example, I'm going to sort the data first by month in descending order, and then break the ties using average.tempf. I'll run that. Now you can see what I have in the output window. Our data sorted first by month in descending order. Since there's 30 days in December, the first 10 rows are all observations in December. But looking over at the average.tempf column, you can see that the values are increasing as you go down. Another dplyr verb is select. Select allows you to specify the variables that are included in your tibble using the column names. All of the variables that you specify in select are included. Variables that you don't specify aren't included. If you'd rather remove variables from your data set by name, you can specify columns to remove using the minus sign. You can also match multiple columns with the functions starts with, ends with, and contains, each of which take a string argument and are going to match columns that either start with, end with, or contain the text you specify. Here I have some examples of the select verb. In this first example, I pipe the weather tibble to the select verb, and I say that I'd like to keep the variables month, day, and maximum.tempf. I'll run that bit of code. Now looking in the output window, you can see that the output from this operation kept the variables month, day, and max tempf, but discarded everything else. Going back to my code, in this next example, what I'd like to do is keep every variable that ends with the text tempf. Remember, these are all of the temperature variables, minimum, maximum, and average. So I'll run this bit of code. And you can see, again, the result of this operation is to keep just those variables that end with the text tempf. Remember, there's also the starts with and contains selectors. So you could select variables based on the text they contain or the text they start with as well. Going back to look at my code. In this next example, what I do is instead of selecting variables to include, I select variables to remove by using the minus sign. So in this case, I'd like to remove the variable year from my tibble, and I do that by specifying select with minus and then the variable name year. Let's run that code. Now if we take a look in the output window, what you can see is that I have my original tibble, except the variable year has been removed. The select verb allows you to keep a subset of columns from your data set. The slice verb allows you to keep a subset of rows. It works by selecting observations using row numbers. You can specify a set of row numbers using vectors. Just as a warning, The output from slice depends on how your data are sorted, which can change. And also if your data are grouped, which is something we'll cover later, slice operates within groups on your data. So sometimes if you use slice, you might not get exactly what you expect if your data are grouped. Let's take a look at this slice verb in action. So in this first example, I pipe the weather tibble to the verb slice. I give the argument 10. This will select the 10th observation from my weather tibble and nothing else. Let's run that bit of code. Now if you look in the output window, what you can see is the resulting tibble only has one observation, and it was the 10th observation from that original data set, which was January 10th. Going back to my code, in this next example, what I do is I'd like to keep a range of observations. I can specify a vector of observation numbers. R will keep all those observations. In this case, I'm using the colon shortcut to select observations 5 through 9. Let's run that bit of code. Again, looking at the output window, what you can see is the tibble that I get from this now has 5 observations, January 5th through January 9th, which were the 5th through the 9th observations from my original data. Selecting by row number sometimes is convenient, but much more often you'd like to include or exclude rows from your data set based on some criteria within the data. You'll use the filter verb to do this. The way it works is it selects observations in your data set using logical tests that you formulate with Boolean logic. Observations for which the test is true are included. Observations for which they're false are excluded. This allows you to combine information or compare information from different variables to determine the criteria for including or excluding observations from your data. Remember, you can also chain multiple logical tests together. You can do that using the and or operators. You can also pipe one filter statement to the next. Again, remember R takes each verb and processes it in order from left to right. Let's take a look at some examples using filter. So in my first example, I pipe the weather tibble to the filter verb. The logical test that I specify is day equal to 1. This will keep all of the observations from my weather data where the value of that day variable is equal to 1 and exclude everything else. Let's run that code. Now if you take a look in the output window, I have 12 observations, which are the first day of each month. So the day variable is always equal to 1. Everything else has been excluded from this resulting tibble. Going back to my code, in my second example, what I'd like to do is keep observations from the second half of the year. So this is months 7 through 12. I can use the filter verb again here, where I filter to observations where the month variable is greater than or equal to 7. I'll run that code. Again, taking a look in the output window, you can now see that I only have 184 observations in my data, the second half of the year, starting with observations on July 1st and then going down. Going back to my code, in this next example of the filter statement, I chain 2 logical tests together. So what I'd like to do is keep just days with high temperatures that were between 75 and 85 degrees. So in my filter statement, my first logical test is maximum.tempf greater than or equal to 75. Then I use the and operator, and a second logical test, maximum.tempf less than or equal to 85. My resulting tibble should have observations where this variable is between 75 and 85. Let's run that. Now if you take a look in the output window, you can see that there are 82 observations where the maximum temperature is between 75 and 85. Each of these verbs that we've seen so far performs small operations on the data. It may not be immediately clear how they're very useful. The real power of dplyr is that you can chain all of these operations together using the pipe. Again, this leads to more readable code. Each verb is going to execute one data manipulation step, getting you from your starting data to your ending data. And it makes it very easy for anyone who's reading your code to follow the logic of the person who wrote the code. And I think this becomes obvious by way of example. So suppose that I wanted a list of the 10 warmest days in College Park during August. If you think about how you would do that, if you were just given the temperatures and dates for every day, how would you find the 10 warmest days? You'd start with your weather data. You'd look at only days in August. You'd sort those days in August from highest to lowest temperature, and you'd keep the first 10. Those would be the 10 warmest days in College Park in August. This is exactly how you would implement this in dplyr code, breaking this down into a series of discrete steps and chaining them together using the pipe. You would start with your weather data. This is just the weather tibble. You'd like to look at only days in August. So you're going to take that weather data and you're going to pipe it to a filter statement where you say month is equal to 8. August is the 8th month of the year. The result of this operation will be that you will only have observations from August. After that, you'd like to sort data from highest to lowest temperature. Again, you could pipe this result to the arrange statement and then sort by maximum.tempf in descending order. So now, again, you have, as a result of these chained operations, the weather data in August, starting with the highest temperature and then moving downwards from there. You'd like the 10 hottest days. So what you'd like to do is keep the first 10 observations. Again, you can do that using the slice verb, keeping the first through the 10th observations. The last thing you might like to do is store this result. And again, you can do this using the assignment operator and store it in a new variable called hot.days. So let's go ahead and do that in R. Here I have the exact same code that you saw on the slides. I take the weather tibble, I pipe it to the filter verb, I keep where month is equal to 8, August. I then pipe that to the arrange verb. I sort in descending order by maximum temperature, and then I pipe that to the slice statement to keep the first 10 observations. Again, reading through this code, it's very obvious what happens at each step, and it's easy to follow my logic, getting from my starting data in weather to my ending data that I saved there in the variable hot.days. Let's run that code. Now again, because I saved this to a variable, there's no output in the output window, but you can see over in the Environment Explorer, I now have a new tibble of data, hot.days, that has 10 observations, again of 6 variables. We can take a look at it by printing it out. Let's do that. Now looking in the output window, what you see is I have a tibble of 10 observations, and this is the 10 hottest days in August in College Park. In descending order of temperature, the hottest day was 91.4, and of those top 10 days, the 10th hottest day was 86. So this was just a simple example of using dplyr verbs to wrangle data, but it should serve as a template for your data wrangling workflow. You'll generally start with some data, you'll connect operations with the pipe, you'll have no more than one operation per line. Each operation is going to perform a single data wrangling step in order, and then you're going to save those results to a new variable at the end using the assignment operator. By following this prototype, your code is going to be readable. Again, new lines break apart logical steps. Indentation is going to group operations. And it's also going to be transparent. It's going to be very easy for anyone looking at your code to follow your logic from start to finish. This is the power of using dplyr for data wrangling, because it makes it easy for you to construct code, to perform data wrangling tasks, and obvious for anyone who reads your code all of the steps that you're proceeding through to get from start to finish.